Hi folks, welcome back to 5.1, not 6 point something, 5.1. This is part 3 of the video series. So as a quick refresher of what we just did in part 2, we talked about this idea of approximating area. We used something called LRAM, or a left rectangular approximation. And with the left rectangular approximation, we were picking the y values on the left-hand side of the rectangle to help us figure that out. Switch gears a little bit to the right rectangular approximation. We were picking right y values from our graph to help us figure out the height of all of those rectangles. Now, the nice thing about what we did is that because we split it into even pieces, all of the bases were the same, and we could just factor that out and have less numbers to type into our calculator. Okay, so now we're going to move on to two other types of approximations, and we're going to use the same graph. So here we are, we're going to approximate with something called MRAM, and we're going to approximate with trapezoids. And so before I get started, I'm going to go ahead and copy down my XY table that I wrote above. So 0, 0.5, 1, 1.5, and 2, and 0, 0.25, 1, 2.25, and 4. And I'm going to plot my x squared graph on both the graph for 3 and the graph for 4. Four. And 0, 0.25, 1, oh, 2.25, and 4. And I'm going to go ahead and connect those with the graph. Great. Okay. So what's different this time? If we're talking about MRAM, I'm still going to take the bottom and I'm going to cut it into 4 equal pieces. Okay. And if I wanted to do trapezoids, I do the same thing. I'm going to take the bottom, the X, and I'm going to cut it into 4 equal pieces. All right, the equal pieces part is really important. We don't want to have ones that are like, some are big, some are small, because then they won't all have the same base, and then we can't factor that out, okay? So when we're using the rectangular or the trapezoidal approximation, it's nice to be able to have one thing be the same for all of them. And that gets really useful if you ever wanted to program it, like what if you cut it into 100 rectangles or 1,000 rectangles? That would be more useful, okay? So we're going to do the same thing here, where we're going to draw those vertical dividers in our graph. And I'll do the same thing down here for the trapezoids. Okay, so I've drawn my vertical dividers. Now with the LRAM, I picked the left value, and with the RRAM, I picked the right value. But with the MRAM, I'm going to pick the value that is literally right in between. And so halfway between 0 and 0.5 is going to be 0.25. And that will give me the height of that rectangle. So it's almost like I'm splitting the difference. Some of it's above and some of it's below that black line. Now if I move to the second rectangle, halfway between 0.5 and 1 is 0.75. And when I go up to the curve, it's right about there. And so my rectangle, I can draw something like this. And I'm going to do the same thing for this one. The middle's about here, and I'm going to go up to where it hits the graph. And that will be my rectangle. And then the last one, this is about halfway, so I'm going to go up to the graph, and that's about halfway. Okay? So this light blue, those are the rectangles, this one, this one, this one, and this one that I want to use. Now, you'll notice that these all are not as overestimate or underestimate as we had in part 1 and 2. It's more like a nice balance. And so that's the nice thing about the MRAM. Okay, so let's set this up. We know that all of the rectangles have a base of 1/2. All right, so I can factor that out. And then I want to find the height of every rectangle. So I don't want to use f of 0 because that would give me there. And I don't want to use f of 0.5, but what I want to use is f of 0.25 because that's in the middle of 0 and 0.5. And then I want to find f of 0.75 because that's halfway between 0.5 and 1. And then I'm going to skip down here, plus f of 1.25, because that's halfway between 1 and 1.5, and f of 1.75, because that is halfway between 1.5 and 2. Now, the downside to this MRAM is that I don't have the y values on my table, so I have to remember what my function one was, which was x squared. And so really I'm saying f of 0.25 is 0.25 squared. And f of 0.75 is 0.75 squared. And f of 1.25 is 1.25 squared. And the last one will be 1.75 squared. Okay, so let's type that all into our calculators. See what we get. And it turns out that this approximation is 2.625. Okay? Now the trickier thing also with MRAM is I don't know if it's an overestimate or an underestimate, but it certainly looks to split the difference because I had a 1.75, which was way too low, and a 3.75, which was way too high, and now I have something kind of in between. So it's like a little bit of a Goldilocks situation here. Okay, so I can't say for sure if this is an over or underestimate, so I'm going to leave this for right now. But let's go ahead to that fourth question. Approximate the area with trapezoids. Okay, so trapezoids is 1/2 base 1 plus base 2 times height. And the nice thing about the trapezoids, let's see what happens when we draw them visually on our graph. So I will start with the last one because it's the biggest one, maybe the easiest to see. So I've got a trapezoid, okay? But not like we normally draw them. Like we normally draw them this way. But in the case of trapezoidal approximation, our trapezoids stand up. Okay, so it's a little bit of a rotation. So here's my trapezoid standing up. So I'm going to go ahead and connect those two endpoints with a straight line. And that actually looks pretty darn close to what I have on my graph. So that's one trapezoid. I'm going to draw this second trapezoid. So here, and here, and here. Oh, so these two trapezoids actually share a side. That's going to be important in our formula. Okay, second trapezoid. Oh, share side again. Okay, we've got that. And the last one actually kind of looks like a triangle, and that's okay. But one thing I did point out was that some of the sides are shared. And so we need to think about which ones are shared and which ones are not, okay? So let's go back to the black color. Okay. This one, this y value here, is only going to count one time. because it's only in the smallest trapezoid. And this endpoint will only count one time in my trapezoidal approximation because it's only in the rightmost trapezoid. But all the other ones in the middle, this one counts twice because it counts for the tiny one and the one next to it. This one, rather, is going to count twice. This one is going to count twice. This one only once, so twice, 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 once. Now, in this case, because we rotated our trapezoid, what we have on the bottom that is the same for all of them is that the height of the trapezoid is 1/2. And the height of the trapezoid is 1/2 because they're all standing up, okay? So that trapezoid formula, we've got 1/2 times base 1 plus base 2 times height. But I'm actually going to write that as h over 2 base 1, let's write it here, h over 2 base 1 plus base 2. Okay, so let's fill in what we know. I know that every trapezoid will have h over 2, so that'll be 1/2 over 2. And then I'm going to go ahead and fill in my bases. So this one is f of 0, that gets counted once. Plus this one is f of 0.5, but I'm going to count it twice. Plus this one is f of 1, but I'm also going to count it twice. Plus this one is f of 1.5, and I'm going to count it twice. Plus f of 2 only gets counted once. Okay? So let's calculate that out, see what we get. 1/4 times f of 0 is going to be 0, plus 2 times f of 0.5 is 0.25, and I'm just getting those numbers from my table back up here. Plus 2 times 1, plus 2 times 2.25, plus 2, whoop, not 2 for the last one, just 1 time, plus 1 times 4, and let's add that all up and see what we get. So 2 times 0.25 plus 2 plus 2 times 2.25 plus 4. And I should get an area of 2.75. Okay? Now, just based on looking at our two pictures, I might be more convinced that question 4, the trapezoids, is closer than my MRAM in the blue from number 3. Okay? So we have, just to review, 4 cases. We've got LRAM, which in this case was an underestimate, but depending on the picture, it might not be. We had the RRAM, which in this case was an overestimate. We had an MRAM, which in this case seemed to split the difference, and then we had the trapezoids that are standing up, and this one seemed to be perhaps the most accurate, but we're not sure yet. Okay? So this is where we're going to stop for part 3 of the video. When you come back, we're going to take a look at how do we know whether things are over or under approximates. All right, see you back here.